After the tone, please state your name followed by the pound sign.
All right, folks, welcome to the Young Minds series, number 6. My name is Kartik. I am the pre-sales lead for Central Division, also Distinguished Engineer at EMC. If you guys could mute your own lines, I'd really appreciate that. There's some static on the lines, otherwise I will have to do a global mute. Well, thank you, I'd appreciate that. So far, we've gone and explored the world of application development and application deployment. We've talked about infrastructure as a service only minimally, and we've mainly been focusing on platform as a service. So this is brings us to an interesting sort of juncture, because the platform as a service, and we talked a lot about Cloud Foundry, about how that is deployed, and I was able to show you a couple of applications of how it runs on the Web Services Cloud, which is hosted currently by Pivotal. And but it begs the question, okay, what does this run on? And it runs on an infrastructure as a service. So let's explore in the next few sessions what infrastructure as a service really is. Really, it's cloud, right? In the Platform 3 type terminology of social, mobile, big data, and cloud, this would be the cloud piece. And from our standpoint, from the Federation standpoint, we're talking about platform as a service, about cloud, and we're talking about data lakes. And we'll talk about all three of these. But with the focus for today, I want to talk about infrastructure as a service. So from the viewpoint of platform as a service, the core value propositions for this is, first of all, it's integrated DevOps, which means all the stuff happened completely, independently of any human intervention. All the right code found in the right place. The full stack got orchestrated from operating system up and from infrastructure down, until all the developers had to worry about was coding the business logic in the framework of their choice. So be it Java on Spring or Ruby on Rails or whatever, we were able to do all that kind of stuff very easily. The other big benefit was the ability to scale. We were able to scale transparently. Folks, please mute as soon as you join in. And this was more advantageous. I'm gonna globally mute, okay?
Presentation mode is now enabled.
All righty. And the third, but equally important benefit was that these applications are fully portable. That is, you could move them from one cloud to the other, and I'll demonstrate some of that also today. And examples of this were, one of course was Pivotal CF, and we talked a little bit about things like Heroku and Azure, and these are standard platforms as a service. The only difference is that we can deploy PCF on-prem as well, while Heroku and Azure is also starting to do that, but usually these are in the cloud. From an infrastructure as a service standpoint, what we traditionally understand by infrastructure as a service is, hey, there's standard infrastructure components such as storage and compute and network. And this is what most of these usually provide, is storage, compute, and network. And we know an offering from VCE, vBlock, which provides this. However, I will argue that just the hardware alone doesn't cut it. We need a little more. We need a management and orchestration stack along with this. Examples of this, of course, the largest one, and there are two broad realms. If you look in the public realm, Amazon Web Services is often touted as the 800-pound gorilla in this field. vCloud Hybrid Services has recently been introduced, and that's very nice. And then CSC has their BizCloud. And there's a host of others over there too, Rackspace, Savvis, Paramark, and all of these are external public clouds, some hosted by service providers and some completely in the cloud like Amazon. And on the private cloud side, we have the number one offering here, of course, is through VCE, the vBlock, and there are other contenders in the converged space as well with management and orchestration stacks that go with them, including from IBM and others. But the kind of infrastructure as a service we're going to be talking about goes a little beyond just offering storage, compute, and network. I mean, that alone is not, is necessary but not sufficient. So you'll see variants offering various operating systems incorporated with the storage, compute, network stack. You'll see examples of database as a service or storage as a service, and in some cases things like Hadoop also consumed as a service, or NoSQL technologies consumed as a service. All of these are sort of more or less in the infrastructure as a service, although one might say, hey, aren't these applications? Yeah, maybe, yeah. But really, they're offered as infrastructure. So for the developers out there, all this is infrastructure. These are services that they use, and therefore some infrastructure as a service will be able to do that. So what I want to show to spend some time with you guys today is to talk to you about Amazon Web Services in quite some detail, right? So what is AWS all about, really? And let's clear up a little bit of terminology here before we get started so people don't get lost. Probably one of the best-known services from AWS is EC2, right? Elastic Cloud Computing, and this is really compute as a service. And what that means is that I can literally rent out or instantiate CPU cycles on demand from a common shared multi-tenant infrastructure. There are ways to make it semi-private, but mostly, and there are ways to federate this also with an internal enterprise. But what you really want to focus on is that this is compute as a service. Closely affiliated with EC2 is this idea called an AMI, or an Amazon Machine Image. And what this is it's a template, all right? And what this lets you do is to fire up a particular operating system, or sometimes operating system plus associated software, which is neatly encapsulated in this object called an AMI, and it's a template, and when you want an instance of it, you basically point to it and say, make me one of these. Now, interestingly, the kernel for the Amazon Machine Image is actually outside the AMI image itself. It calls on standard kernels which are established in the industry, which are known to be safe. But the idea of an Amazon Machine Image will show up as we go through this conversation. S3 is something referred to as Simple Storage Service, and this is a service which is one of the earliest services offered by Amazon, actually, which is an object-based store where you can access content through REST or SOAP-based APIs. And as time went on, they realized that they needed some block storage, so they introduced EBS, which is Elastic Block Storage. And this acts and behaves just like standard block storage. There are a few key things which are different, which are actually very relevant to the enterprise, which are missing from EBS. And I will point them out as we go on. And as time went on, people said we really want an environment which looks and acts like an extension of our own data center. So Amazon offers the idea of a virtual private cloud. And this, by the way, is an interesting concept. The rest of the industry has adopted it. vCloud Hybrid Services, as you'll see, also offers this. And what's interesting about Amazon is they also offer a software development kit, or an SDK. And what an SDK does is it provides language bindings to manipulate resources on Amazon Web Services, which allow people to programmatically change the things in the running environments inside Amazon, including provisioning, deprovisioning, decommissioning, moving stuff and snapshots and all that kind of stuff, right? So, given this terminology and that, this is where we are, let's switch gears and have a look at how this actually works. So what I have here, guys, is my own Amazon account, which I will show how to sign in. This is just AWS.Amazon console. Now you can sign up for your own account if you want to, absolutely. And there's a lot of documents over here, and lots of articles and developer tools and all kinds of stuff which you can do over here. So the sign-in is pretty straightforward. I have an Amazon Prime account because my wife and I buy a lot from Amazon, and we do a whole bunch of stuff, through movies and stuff like that. And I created, oops, hang on a second. And I created an AWS account maybe about a month ago or something like that. And it gets in there and says, okay, that's my Amazon Web Services console. So as you can see here, it offers quite a bit more than EC2 itself. I mean, there's EC2, which we'll talk about in some more detail, but there's a scalable domain name service available. But there's a lot of database services, and including data warehousing type services and regular database services. There's cloud deployment and management services which are available. Elastic Beanstalk is a platform as a service. CloudFormation lets you do template-based resource creation. There's stuff on the storage side. They have archival storage. They have S3, which is we just talked about, and a whole bunch of application services along with that as well. So let me, for example, let's have a look at manage relational database services. And you'll see here that you could do a whole bunch of stuff with this by creating your own kind of database as you require, right? So if you look at, say, getting started with RDS, you'll see that just about most of the standard kind of databases are available over here. You can go to and say, hey, that's Oracle, there's SQL Server, there's all kinds of stuff that's available. And so you could create a MySQL database or an Oracle database, and it's not just any, single standard version. They have a lot of versions of this as well. So very, very interesting little service which they provide, which lets you do a lot of stuff. Okay, so so we can go back again to the dashboard over here, and you'll see that in addition to that, they have NoSQL services like Dynamo. Now, you should note that many of them are very, very proprietary, which means if I start to use Dynamo, or if I start to use Elasticache, which is really their version of using Memcached to create a memory fabric, or S3, then I'm kind of bound to that. So it is very sticky once you start using the services. But it certainly offers some advantages because it offers a whole bunch of things at one spot. So let's look some more in detail at EC2. All right, so this is my own EC2 environment. So as you can see, I have a couple of running instances, a couple of volumes bound to that. I have something called a key pair, which I'll explain in a second, which lets me log into my machines and things like that. And I have something called an Elastic IP, which is an IP which is fully dedicated to me because I use it for a whole bunch of stuff. So I like my own IP address. I don't want something that's dynamically associated. I went and got a DNS entry in GoDaddy.com for $10. So I actually have my own thing also for DNS. So let's look and see what my instances are over here. So I have two instances running, as you can see. And one of them is on an instance type called M1 Medium, and the other one is on something called T1 Micro. Now, I'm a cheap guy. The micro class of instances is free. And so you can fire up as many as you like, and it doesn't cost you that much. And I've been doing this for about a month, playing with micros and mediums and stuff like that. And some of them are paid for, like the mediums, and some of them are not. And in case anyone is wondering how much all that cost, I can show you what it actually cost me, from a spend perspective, and it's cost me about $6.42 at this point. So it's been reasonably cost effective enough that I'll probably not expense this and have Chad see the bill for Amazon over here, right? So we can go back here again, go to EC2 and look at the instances again. And what we had was these two instances. So if I look at one of them in some more detail, if I look at the micro instance, for example, you see that this is a Red Hat Linux system. And coupled closely with that is something called a key pair, which lets me access to the system. But it has an external IP address. It has a DNS name associated with it. It has a lot of characteristics, which you expect to find in a regular, running operating system. Now, I could also, for example, look at my other instance, and this is my own copy of Cloud Foundry, Micro Cloud Foundry to be precise, and that's actually bound to my Elastic IP. So this is a permanent address which is allocated to me. I do pay money for that, and that's what really lets me have stability as I do my development. So let's illustrate how this whole process works. Say I wanted to fire up a machine. I would go and say, let me launch an instance. And immediately it gives me a whole bunch of things which I can look at and say, hey, all of these things you can launch. Now, these are all Amazon machine images. So I could take an Amazon Linux version, and they have their own version based on Red Hat. I could go with traditional, Red Hat Enterprise Linux, RHEL 6 or SUSE or Ubuntu. If I go down over here, you'll find that there's all kinds of Windows things I can have. So there's actually quite a lot of variety of what kind of operating systems I can actually, look at. But these are just operating systems. I could go a little further and say, hey, let's look at, what the Amazon Marketplace is all about. And you'll see there's tons and tons of products over here, right? So if I look at, say, what the business products are, for those of you who blog, WordPress, well, and Jaspersoft is well used in the analytics environment. All of these, SAP HANA is available as an AMI, and these all cost money. You can see it's 99 cents an hour and other charges for EC2 on top of that. So there's a fair amount of variety available if you want to look at it, and even more interesting is community AMIs, where there's a host of things available. So for example, if I said, let me look for Oracle AMIs, well, there you go. You got, for those who like Toad, you can get a free copy of Toad. But more interestingly, they got things like Oracle EBS, eBusiness Suite, also available over here. You scroll down a little further, and you'll see OBIE as an OVM available. So there's a tremendous amount of flexibility for what kind of services are available. There are hundreds and hundreds of such things which are available. So what we will do is we will go to Quick Start, and I'll just pick, say, a standard 64-bit RHEL 6.4 image over here. Now what we see is it says, okay, well, so what kind of instance do you want? Like I mentioned, this T1 Micro is free, and that's what I like. And it basically has one vCPU and about 600 meg of memory. And it has EBS storage. We just talked about it. It's not really guaranteeing much performance. It's no big deal. It's a toy instance, and it's good to play with. Now, you might want to go larger than that and say, give me a big box. Get me a general purpose box. Now, these things cost money. Now, I'm running Cloud Foundry on M1 Medium because it's pretty memory intensive. And you can see that it has close to 4 gig of memory and a 400 gig of storage attached to it, and it has a couple of CPUs. So it's moderately sized, but you can get some pretty monster things over here, like 26 CPUs and 30 gig of memory. Now, if you want to go much larger than that, even you can get very large memory guys over here, or you could go to compute optimized systems, which will have 60 gig of memory, extremely 108 cores. There's a series of very, very large machines which they've introduced over here. And all of those are viable, for doing much larger workloads if you like it. But me, as I said, I'm cheap. I'm just going to go with T1 Micro. So I say, all right, so we picked that, and then I say, let's add some details over here. And frankly, I just want one instance. You could add 2 or 3 if you wanted. And, it sets up a default internal network, and I don't have any preference for availability zone. But, if you wanted to, I do a lot of my work in Oregon, which is West 2B. So I said, all right, let me make the machine over here. I won't go much over identity at this point, but, it's standard behavior over here. And I'm going to go shared multi-tenant. I could also go single-tenant hardware. I could go dedicated for a price. Everything at Amazon is for a price. You want to add some more services, you absolutely can. CloudWatch is a monitoring service. You can go ahead and add that as a service, and it'll cost you more money. So next I can add storage, and it comes with a standard sort of boot drive, where the root operating system is installed, and that's 6 gig in size, and I've configured it so you get rid of it if I ever was to terminate this AMI, or rather this machine. Now I could add a new volume and say, now this is elastic block storage, and it could be a standard volume, or it could be one where I provision some minimum threshold of IOPS. So I can specify how much I want, what size I want, etc. But once again, I'm not really going to I don't need extra storage for this demo, so I'm going to get rid of it. And I'm going to say, next I'm going to tag this instance. I can call it something. I can say this is my test RHEL machine, and I can also change the name also to, my RHEL or something like that. And, pretty much I'm set to go. The next thing I do is I say the security group. What this says is, hey, I want to, set up some rules for how you can access this. I'm going to use an existing, what I call storage group, and it's easy enough to create these. And you can see that what this does is it lets in SSH, Secure Shell, HTTP, which we all know, HTTPS, which we all know, and ICMP, so I can ping the box and figure out if it's alive or not. You can change the sources to, narrow it down. You can do a whole bunch of stuff like that. So I say, let's review and launch. So I say, okay, I got everything set up. Now let's go ahead and launch. Now it's going to ask me, hey, how do I actually log on to the system? So the way Amazon arbitrates access to a single machine is through Secure Shell. And what Secure Shell does is it allows you to create a private and a public key pair. And the public key is on the machine. The private key is with you, so you're the only one who has it. If you guys are interested at some time, I will, I'll be happy to do a lecture on the intricacies of Diffie-Hellman key exchange or RSA key exchange if people are really interested in public key cryptography. I'll be happy to do that. But what I'm going to do, you could either choose an existing pair, or you could say, create a new pair. I'll create a new pair just to sort of demonstrate what this is. So I'll create a demo pair. And what this does is it says, okay, I'm going to do that, and I'm going to download that pair. So what it'll do is it'll create a demo pair over here. Actually, I already had one before, so what I'm going to do is I'm going to create another new pair. I'm going to call it demo pair 2. Okay, and I'm going to download this as a key pair. And we're going to say, okay, that's the pair we're going to use. And I'm going to launch these instances. It's as simple as that. So it took a couple of minutes. As you can imagine, somebody who's experienced with this can zip through this in absolutely no time at all. And you get to a point where it's very, very useful, right? So now I can say, let's view my instances. And there you go. My machine is starting at this point. It's starting to fire up. As it boots up and stuff like that, you'll see how this works in like a few minutes. And while we're doing that, what we can do is we can do a little bit of cleanup on what we need to do for the demo pair for Secure Shell to work. All right. So what we do there is, I'm in my downloads directory, which is where I downloaded this key. So I could look at all my keys, and I will find my key pair demo pair 2. Now, one of the rules for SSH is that that key can't be, read by anyone. So I have to change the ownership of that pretty strictly. So I'm just going to say, for the Unix guys out there, what this means. It means make it so. make it so only the owner can read it and nothing else, no one else is allowed to do anything. And you can see that if I look at demo pair 2 and demo pair 1 was the first one that I downloaded, which we decided not to use. So this guy here is only readable by me. So let's see where we are with respect to the machine running, and bingo, there it is, it's running, right? So I can take a look at this and say, aha, so that's what the machine looks like. It's a rel box. It's got a DNS entry over here, so I can access it through this host over here. So I can take that host name, which is the public DNS name, and let's capture that. And what I'm going to do is I'm going to go here and I'm going to do secure shell, and I'm going to say use this key here, and I'm going to say use the user EC2-user and use the host name, which I just captured on the previous screen. And let's do it. Now it'll say I don't know that host before. Should I go and add to it? Should I go and access it? Say yes, and it'll add it there, and bingo, I'm on my machine over here. And you can see that I'm on a rel box over here, and that's all it took really to fire up a box, right? Now we could go a little further and say, okay, let's actually run something on it. And in the interest of time, as I told you guys earlier, I already set up a Cloud Foundry box over here. So now you've seen in previous Young Minds series, I've shown you demos of how this works with simple applications written in Ruby and Sinatra. So for our entertainment, I've written another application in Ruby and Sinatra, and it's a pretty simple application. It's actually one that I've written for EMC World, and it is an application which is written as a lottery system for the Platform as a Service Federation booth. So if anybody of you is there, then please do come and look me up, and you'll see this demo. So what I do is I've written an application using a gem for Twitter, and I get some authentication credentials from Twitter. It's easy enough to do that. You can you go onto Twitter's website and you register the application, and you get all these keys. And what it does is I specify behavior for what to do to go to the top level / directory for the HTTP stuff and the info and I have another directory called tweet and something called a form, and you can see here that I capture some information and I send out a tweet. Right? So let's see how this whole thing works over here. And I have set up Cloud Foundry with a Cloud Foundry, you've seen me do this before with the Pivotal Cloud. Now this is with the Amazon Cloud. So if you notice, this bit here was my Elastic IP address over here, 54.186.79.110, my own little address here. And what I've done here is I've pointed to that, saying that's my Cloud Foundry target. And what I'm now going to do is to do what we've always done before, which is CF push, which takes the application which I've written, which is called PASTweet. And what it does is it binds it to a URI, which is this hk.54.186.79.110, and then it uploads this piece of code up there, and it starts to install it. So this is the magic which we've seen before. This is why Cloud Foundry is so cool, because you can literally upload everything there, and it does all the stuff. So if you notice, it installs a hell of a lot more than it did when I wrote my Hello World programs or Sinatra test programs. And then it goes up here and says, okay, I'm going to create a droplet, and I'm going to start to execute it in Cloud Foundry's DEA. And if you recollect in earlier talks, I think number 4, we talked about what a DEA is. And bingo, that's all I had to do. Now, PASTweet is now running on Amazon on the same machine that we looked at all right? So I can say, all right, so what does this really look like when I go there? And it's actually a pretty simple little app. What I do is I can go to this URL, which I just pointed out, and I get hello world, which is the slash. Now, the interesting part, of course, is in /tweet. And what I've done is to create a little jailbird, and this is the Paz lottery. And the way this lottery works is as I launch this application on Cloud Foundry, the crowd uses their mobile device to go here. And by the way, you're welcome to go here too. This URI right now is running and live worldwide. If you have a mobile device, an iOS or Android device, go ahead and point it at it. Or if you're on a laptop, go ahead and point it at that. So, for example, if I say, I'm saying Young Mind is my first and last name, and I do a submit, I get my two favorite people, Beavis and Butthead, basically saying, hey, your name is Young Mind and your lucky number is 1. And the lucky number was just a random number that was thrown out. And the goal over here is to find the person who has the random number that matches, and if they do, they get a Starbucks card. Now, what's interesting is that when this happened, I also sent a tweet out to Twitter, and you can see that, hey, someone wrote Karthik rocks, and thank you very much. I appreciate that. And Young Mind picked number 1, and Number Lucky picked number 5. This tells me the people who are actually going there and doing this over there. But you can see, it's a pretty simple little app. But you can see the power of how you can take something like that, develop it, and deploy it on something like Amazon. Looks like we got a couple more tweets over there. And cool stuff, pick number 3. Unfortunately, this is not a real lottery. Otherwise, I would have given you a Starbucks gift card. But anyway, point made. That's the way the lottery works, guys, and that's the way Platform as a Service works, all right? So this is what is so interesting about AWS. And now you look at this and say, man, this is very cool stuff, and it's very powerful. Does this mean that this is the future of all enterprise computing? And I want to emphatically make one thing clear. Impressive and interesting as AWS is, there are still some serious issues which make it inappropriate for a lot of the stuff that we actually do in our enterprises, right? And just to illustrate and enumerate what they may be, understand that, the biggest number one issue with AWS. So, it's like, why not, Amazon Web Services is the real question. Oops, sorry about that. Oops. And the number one issue here, guys, is actually cost. I know I showed you that my cost is very minimal, but just so you know, that M1 medium machine that I had added $1 in the last, just all through today. Now that might not seem like much because I actually only ran that particular application for a short period of time. It adds up rapidly. And it adds up even more as we start to add more services which are related to this. Every single time you can show that the cost of a well-run private cloud or a well-run hybrid cloud is significantly lower than what you would run if you ran 100% on Amazon. As I mentioned, there's the risk of lock-in as well, right? So where was the lock-in? Either I use AWS services like Dynamo, like S3 and API, or if I start to get locked into their SDK, and I start to orchestrate my workloads at AWS using their SDK, which has some great bindings, by the way, to all kinds of languages. But when I do that, then I get tied into Amazon. Another major issue with AWS is once you're there, there's the issue which you have to deal with, which is called data gravity. I hate this term. I'm a physicist. This is more like data inertia. So which means once you start to go over about 500 terabytes or so, and thank you very much for the St. Louis team for doing this calculation for me. After about 500 terabytes or so, it starts to be really, really time-consuming and expensive to get out of there. It can take 30 days to get out of Amazon once you start having that kind of data. So if you're in for the long haul, it might work. If you're locked into all these services, it may work. But we've all seen this movie before. We've all seen, you know, the time when hosting was supposed to take over the whole world and everybody was going to go to hosted environments. We've seen outsourcing take over the whole world, and that got reversed. You know, we've seen a whole bunch of such kind of movements. Application service providers taking over the world. That got reversed. What happens when the next alternative to Amazon shows up is, do you want to be stuck in Amazon? And that's really what it looks like at this point, and this is what is really, really dangerous, right? There's inherent risks because of multi-tenancy. For the most part, most of the stuff that we see is in a shared environment. Even the virtual private cloud type environments are not as isolated as they might make it out to be. They let you federate it with an enterprise, but you know what this causes is a lot of systemic issues in shared workloads. So outages at Amazon are always spectacular. You don't have one customer going down. You have, you know, hundreds and thousands of customers going down at the same time. And some of them are very, very expensive outages. Now, they don't happen too often. Now, let's give them credit where it's due. They're very good. But at the same time, this is a fundamental risk that has to be dealt with. And to do this, you need to acquire high availability services like availability zones, right? We saw this when we were configuring the instance, which availability zone do you want, and I picked one. You could pick multiple and mirror these services across them. And guess what that means, right? All that automatically means money. It makes it more and more expensive as you start to go into more and more advanced kind of services. Another thing which is rather hard to manage is performance. Now, I showed you guys how you can guarantee some IOs per second, but when it really comes to high throughput or low latency type of applications, the kind of granular control that you need and the instrumentation that you need to make sure that you're delivering on the SLAs that you promise are very, very difficult to come by when you try to configure something like Amazon. And lastly, there's this idea called culpability, right? What I mean by culpability is, imagine if you're if you take $250,000, or your sales guy takes $250,000 of his money, and he put it in a bank. If the bank goes south, the FDIC insures that money. You'll get your money back, and you don't care what the money is as long as it's green and it spends. You're happy with the fact that 250K is 250K, and that's what you get back. There is no FDIC for data. If there's a data breach, there's a systemic breach of Amazon, the culpability lies within the enterprise, which means you're at the mercy of the security model that Amazon has, and they have a pretty good security model. But that being said, it's also one that if you crack one, you crack them all type stuff. So it starts to become more and more risky as you go there. And the real reason why CFOs and chief legal officers and COOs and CEOs are hesitant to go towards the full cloud infrastructure is because of this culpability issue. What this means is they still want to retain a lot of their stuff in-house and only take parts of it at best to any kind of external cloud provider out there. This starts to limit a whole bunch of use cases around what really goes out there and what doesn't. Yes, most of our customers are looking to do AWS or some similar service, but generally speaking, you'll see this in test dev. You will see this in applications that scale horizontally. And why is the reason? Because, frankly, it's also related to this availability thing. If you recollect, I talked about elastic block storage having a limitation, and the limitation is it's only one instance at a time, which means I can't have shared block storage, which means I can't build a traditional cluster like I usually do inside the enterprise. There is no shared block storage kind of option available at AWS that I know of. And the way you share EBS is through NAS. And as you know, there's only so many clusters you can build with NAS. Sometimes you need I/O failure fencing, you need locking, you need all those kind of things. And so you can't really deploy large-scale mission-critical applications on AWS. And that's one of the issues over there. So if an application can scale horizontally, like web apps and things like that, we'll see some of that. And also applications where, somehow you can build in app resiliency. And you're not reliant on infrastructure resiliency to do this, because infrastructure resiliency can be pricey, A, and B, there are some kinds which you can't do because of limitations of their infrastructure over there. And lastly, the ones which are not very data intensive. Now, I do know that there are people, who run Hadoop and stuff like that over there, but if you're going to do data-intensive applications, remember the kind of lock-in that you had when you had to come out. It takes a heck of a lot to actually get the data out of there. You're fine as long as you plan to live there for a very, very long time, or all the data is throwaway. Otherwise, it seems to be somewhat of an issue. So this is why we advocate that even if you do go to Amazon, Amazon for us means that hedge your bets, use Pivotal Cloud Foundry. This will let you deploy it on a private cloud, on a hybrid cloud, or an external cloud, or with an external service provider. So overall, I have to emphasize over and over again, hybrid cloud is the way to go. And this is where the entire EMC strategy is focused on, and these are the reasons why AWS, despite it having such a slick interface and such wonderful choice, etc., is still not always the right solution for everybody, all right? So I think I'm probably way over my time at this point. Let me just do a quick time check. Yes, it's 4:40, which is about the upper limit of where I like to be. So I hope you guys found this useful. I really wanted you to get a good feel for, how this, how AWS really works, and encourage you to sit and play with it if you like. It's easy enough to get a free account. You can fire up your own machines and have some fun. I did do all my development on AWS and a lot of my, a whole bunch of the testing for the applications I write over there. And the idea of a cloud is seductive, because even more interesting than what I did at AWS is what I didn't have to do. What I didn't have to do was to talk to another soul about getting any of this done. I only had to focus on getting my work done. I didn't have to go and say, hey, can you build me a machine? And, oh, my machine is too small. Can you build me a larger machine? Oh, I need a network. I need an IP address. All of that I was able to do pretty much self-service. So a private cloud absolutely has the same kind of characteristics that AWS does. AWS has thousands of choices. However, most enterprises don't need thousands of choices. They need 10, 20 choices, and that's really all you need. And that's the part that we need to be very cognizant of, that kind of an environment we can absolutely build for our customers, and that's what's critical. Alrighty, so let me stop here, guys. Questions by chat, or I'm going to try once again to unmute this thing, but I've not had luck so far, but we'll see. Okay, my line is unmuted now. Let's get started.
Presentation mode is now disabled.
Okay, presentation mode disabled, which means hopefully people can hear me. Can you guys hear me?
Yep, can hear you, Kartik.
Okay. Oh, great. So we can hear you too. I mean, I can hear you too, so that's fabulous. So any questions, guys? Then now you see why customers find AWS so seductive? It's like literally like falling off a log, You go in there and you can pick all your stuff right here, a couple of minutes, all kinds of choices, and bingo, you're up and running. You hardly have to do anything more. But key thing to remember, key takeaway, do not get freaked out by this. There are 101 reasons why a private cloud and a hybrid cloud with a service provider, be it CSC or or AT&T or Verizon or whoever it is, has a lot more advantages, and going with Pivotal gives you that platform independence so you can move in and out of such a cloud environment. Okay, questions? Wow, silent crowd today. All right, going once.
Kartik, can you hear me?
Yes, I can. I can hear you.
Sorry, culpability. Can you describe that again as you described it?
Yeah, so the idea of culpability is who is culpable for breach of the integrity of a corporation's data. The governance right now is much more around, if Amazon has a breach and you lose the data, the data is compromised or destroyed, the corporation is held accountable. Okay, so like it flows from a very old management principle. You can delegate authority, you cannot delegate responsibility. So corporation is ultimately responsible to answer to whoever is governing them, like the SEC, saying what happened. Like in the case of the Target breach, nobody's going after that, heating and cooling company saying you're the guy who's at fault. You let him in. Ultimately, it's Target that's responsible for that. So that's a great burden over there, and it's a little tough to deal with that in the minds of most of the senior executives, most of the business executives and our customers. Does that answer your question?
It does. A question, I guess, somewhat related is, does Amazon, who's known for mining data, right, all the data they get from all their customers,
yep.
Do they have access or do they have rights to the customer's data that uses these technologies? Can they go look at that data, use it for their needs and mine it?
No. All the AMI images themselves are encrypted images. So the data inside an image or the EBS storage on it, etc., is encrypted, and I believe the secret key is needed to be able to access that data. So Amazon cannot look at your personal data, but they absolutely can look at things like your usage and any kind of other shared data that's out there. If anybody knows differently, let me know. It's encrypted. Somebody asked a question about Young Minds 5. My bad. I got real busy last week. I do have the session recorded, and I will send out the links for it. We will also upload it onto the website as well. Okay. So the Young Minds website is there at I believe it's at bit.ly EMC Young Mind. And this is kind of the public-facing repository for these recordings. And my Twitter handle is Warrior Monk EMC. For anybody not following me, shame on you. I need more followers.
Dyer, I can't see that part of your screen wherever you're writing that right now, so maybe send that out in your follow-up note again. And I think you have.
I will. I absolutely will. Yeah, oh boy, I didn't realize that parts of the screen couldn't be seen. My bad. Okay, alrighty?
No problem.
Any other questions, guys? Okay, folks, if not, have a great week. It's a long quarter, and wish you all good selling. Thanks.